This is part 2 of section 5.3. We are given that secant of theta is equal to negative square root 3 and that sine of theta is a positive number. We're being asked to find all of our basic double angles. So first of all, let's figure out where this is. Sine is positive here and here. So it's either quadrant 1 or quadrant 2. Secant being negative means that cosine is negative. Cosine is negative here in this quadrant, so this angle must be in quadrant 2. Okay. Secant of theta is negative 1/3. That means that cosine of theta is equal to negative 1 over the square root of 3, which is the same thing as negative square root 3 over 3 if we choose to do that. Okay, so this would mean that this is a 3 here. Actually, let's just keep it as a square root 3. Let's do this one, not worrying about the rationalizing. It doesn't matter, you're going to end up with the same answer no matter what. Okay, so this would be negative square root 3, and that means that our x coordinate here would be a negative 1. All right. Now, if I go to the Pythagorean theorem and that this is a negative 1 here, I would have 1 squared plus my y squared, whatever that is equal to square root 3 squared. So y squared is 2, so y must be the square root of 2. So I have that. So my cosine is negative 1 over the square root of 3. Sine of theta is going to be the square root of 2 over the square root of 3. And tangent of theta is going to be negative square root of 2. Square root of 2 over negative 1. Okay, so sine of 2 theta, sorry. Start over again. A is sine of 2 theta. This is 2 times sine times cosine. Okay, so I end up with negative 2 times the square root of 2 over 3. And if I needed to rationalize this now, I could, but this is a good answer. And really, I mean, you can rationalize all along. It will work out. You're going to have to reduce your fractions more and all that kind of stuff. But leaving it unrationalized until you finish your calculations also makes a lot of sense. It's up to you, though. Part B, cosine of 2 theta. Let's do cosine squared minus sine squared. And this will be 1/3 minus 2/3. So that will be negative 1/3. Okay. In part C, tangent of 2 theta. Well, that's going to be negative 2 times the square root of 2 over 3 divided by negative 1/3. So this ends up being just 2 times the square root of 2. Okay, so now let's use a double angle formula to find the exact value of each expression. So I'm given 2 times tangent of 75 degrees is divided by 1 minus tangent squared of 75 degrees. If you look at your formulas, I have this basic setup here, right? I have 2 tangent of an angle minus divided by 1 minus tangent squared of that same angle. So that means that this equals tangent of 2 times 75. So this equals tangent of 150 degrees. And this is one of the angles that we do know. It's on your unit circle, and it is negative square root 3 over 3. Okay. Find the same for 1 minus 2 times sine squared of 165. 1 minus 2 times sine squared of an angle. I have this. So this equals cosine of 2 times 165. Okay, so this is cosine of 330 degrees, and that is exactly the square root of 3 over 2. Okay. Now let's do this one. We want to verify each identity. If I have 1 plus cosine of 2x plus 2 times sine squared of x is equal to 2. And here are my double angle identities. Since I have a cosine of 2x here, I'm going to look at these. And since I have a 2 sine squared of x and I have a minus 2 sine squared of x, I'm hoping that maybe that one will go away. So I'm going to replace this with this. 1 plus, instead of cosine 2x, I have 1 minus 2 sine squared of x. So that's right there. And then I have plus 2 sine squared x. And I'm hoping that it equals 2. And this are going to cancel, and I end up with 1 plus, I can't write, 1 plus 1 equals 2, which is of course true. So that will be verified.